In the last video, we learned how to convert something in standard form to polar form when they're written as complex numbers. So that's what this problem is. That's helpful for pretty much any of the calculations I've taught in these videos, but especially for the complex roots. So let's talk about how to do complex roots. A complex root just means you're doing some sort of root, so an nth root. I'll do a general nth root of any complex number. So it feels a lot like the power rule. You'll do the nth root of your radius, and then instead of multiplying by n, we'll divide by n. But this is where it's slightly different. With nth roots, you will have n solutions. So that means if I have a cube root, I'll have 3 solutions. If I have a fourth root, I'll have 4 solutions, and so on. To find all remaining solutions, I'm going to add a full rotation, which is 2 pi in radians, divided by the number of solutions. And we'll just add that a certain number of times. The k value is representing an integer, representing that we're adding it a certain number of times. Obviously, if we're in degrees, the only difference would be we would do 360 degrees divided by n times the k value. So let's jump right into a problem. So we're going to have to do that conversion like I just talked about on the previous problem. So here's our value. A couple things to note with the instructions though. So we're going to find all the complex roots. In this problem, we're going to have 2 answers because we've got a square root, or square roots we're looking for. But then it says, when possible, write the root in the form a plus bi. So write it in standard form. Otherwise, we're going to leave it in polar form. So I want to talk about what when possible actually means. That just means it's one of your typical unit circle angles. So when I say typical, the ones you are used to. So pi 6, pi fourths, pi thirds, pi halves, all around the whole unit circle. That means if your answer gives you something like pi 18ths, you do not have to convert it to standard form. You just leave it in polar form. All right, so we're going to go ahead and first convert it to polar form, which seems in some ways counterintuitive, but it's going to be a lot easier. So I'm going to go ahead and convert this by finding my radius first. So my x value is 2 root 3. I'll square that. My y is -2, and I'll square that. And that equals my radius squared, like we learned a couple lessons ago. So this would be 16 is my radius squared. And if you take the square root, we end up with an answer where our radius is 4. Now, interestingly enough, if I went and divided both of these by 4, by that radius, you would end up with an exact unit circle coordinate. And that unit circle coordinate is in the 4th quadrant, right here. So it would be square root of 3 over 2, -1/2. The angle for that coordinate is 11 pi 6. You could also say -pi 6, but I'll go ahead and use 11 pi 6. And that is going to be the angle for our problem. So let's go ahead and write it in polar form. So we've got 4 as our radius. I'm going to do shorthand, and then 11 pi over 6. Now remember, we're finding the square roots. So let's go ahead and go through that process. So I'll go ahead and do the square root of all that. Square root of 4 is 2. And then the angle, I'm going to divide by 2, which is the same as multiplying by the reciprocal. So multiply by 1/2. Now there's 2 solutions we said. So solution number 1 would just be 2 cis, and then 11 pi 6 times 1/2 is 11 pi 12ths. Now that is not a typical unit circle angle, so thankfully we are done with that one. And now we just need to find our second answer. Second answer will have the same radius. We're just going to have a different angle. And we find that angle by adding a full rotation divided by the number of solutions. So in this case, pi. 2 pi over 2 is pi. So if I add pi, I end up with 23 pi over 12, which is once again conveniently not a typical unit circle angle, so we can stop right there. So those are your 2 answers. So let's do another one. I had a bit of a typo, so I changed it a little bit ago, but we're going to do a cube roots for this problem. Once again, it's going to be same instructions, so it's going to be easiest to convert this to polar form first. Now, polar form for this one, 0 squared plus 5 squared equals r squared. There's no x value. The y value is the imaginary part, which means our radius will just be the 5. If you solve that, you'll just get 5. The angle in this one I actually really love. It's pretty easy. Remember, the y-axis is the imaginary axis, so our point will be on the y-axis, which is an angle of, and the positive y-axis, so it's an angle of pi halves. And one more little note before we start, because we're looking for cube roots, we're going to have 3 answers. So let's go ahead and write our polar form first. So we've got 5 cis pi over 2, and we are trying to find the cube roots of that, which I'll break down a little bit. So we've got the cube root of 5 cis, and then pi halves. I'm going to multiply by the reciprocal of 3. That's like dividing by 3. So let's find solution number 1. Solution number 1 will be the cube root of 5. And we'll just simplify this. Pi halves times 1/3 is pi sixth. Now, that is a typical unit circle value, so we'll do all of the final conversions at the end. Let's find all 3 of our angles or values first. So we've got the cube root of 5 cis, and then remember, we're going to take a full rotation, which is 2 pi, and divide it by the number of solutions, which is 3, and that's what we're going to end up adding to this value. Pi 6 plus 2/3 is 5 pi 6. And that also is a typical unit circle angle, so we will have to convert that one as well, but let's do our last one first. The last one, I'm going to go ahead and do the same thing where I add 2 pi thirds one more time to get my third solution. And that will give me 3 pi over 2, which is unfortunately also a typical unit circle value or angle. So here is the part where we convert. Yeah, I'll switch to this color. So for solution number 1, in fact, this is what I do for all of them. What I first do is I figure out the coordinate on the unit circle for that angle. So pi 6 is square root of 3 over 2 1/2. To convert this for solution number 1, all I'm doing is I'm multiplying the cube root of 5 by both of these coordinates. That's because we're multiplying the cube root of 5 by the cosine of that value and the sine. And remember, the sine or the y value is going to be the imaginary part. So this would just give you a solution. You can just put it right on the numerator. So cube root of 5 square root of 3 over 2. So that's for this first one. In fact, let me just highlight the coordinate. And then plus cube root of 5 over 2i. Remember, this is the imaginary part. And this 1/2, I'm multiplying by a 1, so that's why I didn't write the 1. That one is now converted. Okay, let's go to the second one. Same idea. So for the second one, I'm going to think about the unit circle really quick. 5 pi 6 is over here. And that is negative square root of 3 over 2, positive 1/2. Which means you'll notice that they are essentially the same coordinate, just there's a negative on the x value. So answer number 2, we'll just have a negative for the x value, or for the first value, which is the x value. But otherwise, every other part is the exact same. So kind of convenient. Let's make that a little better. Okay. And then the last one, which actually is going to be the easiest one, because that coordinate is just 3 pi halves is right here, so 0, -1. So for the last coordinate, cube root of 5 times 0 is 0. So just have negative cube root of 5 I, which usually we put the I before the radical. So I'm going to write that a little bit more properly. So it's negative I cube root of 5, just so we don't accidentally put it under the radical. And those are your solutions. For the last problem, we are going to leave our answers in polar form, but we're also going to make sure it's in degrees. But we don't have to do with that last conversion, so that kind of ugly conversion we did at the end. This time we're doing a 4th root, so this is 4 solutions, but we're still going to go ahead and convert this to polar form. It's currently standard form. Once again, just like last time, because the negative 81 represents our y value, you would get something like this. So 0 squared plus negative 81 squared equals r squared. Our radius is just going to be the 81. Because if you take the square root of 81 squared, it's 81. Theta, remember this is the y value because it's the imaginary part. So it's going to be on the negative y-axis. So that's going to be 3 pi over 2. But because it said to do degrees, I'm going to have to use 270 degrees, which is fine. So let's go ahead and write our first part down. So we've got 81 cis 270 degrees. And we're doing a 4th root of all of this. So there should be 4 solutions. Let me change colors so we can tell this is a little different. And let's actually move it down a bit because I'm going to run into things over here. Okay, so 4th root of 81 is 3. So we've got a 3 cis, and then I'm going to do 270 divided by 4. It's like multiplying by 4. So 270 divided by 4 will help me figure out my first solution. So we've got 3 cis, and that would be 67.5 degrees. And then we get to keep it in polar form. So we're just going to go ahead and keep adding. So remember, 360 degrees is a full rotation. I'll divide it by 4 because there are 4 solutions. That would give me 90. So we're adding 90 each time. So 67.5 plus 90 is 157.5. So we've got 3 cis 190, or sorry, not 197, 157.5 degrees. And then I just keep adding. So next one would be 3 cis. If I add another 90, I get 247.5 degrees. And then the last one, I'll add another 90. So 337.5 degrees. And then I'm done. Those would be my solutions for this one.